Here we're going to use Newton's second law to solve a problem for a particular force. We started this one in class, but we didn't finish it. So let's, now I'm going to start over. Okay, two things to remember. There are always two ways to find the net force. So I'm going to write those at the top here. One way is using Newton's second law rearranged, mass times acceleration. And then the other way is to add all the forces on the diagram. So that's kind of just the definition. Okay, so in this problem, we have a tug of war going on, and they're actually just giving you the mass of the rope at the very beginning here. So we know the mass of this piece of rope, and they're pulling on it in opposite directions. We have a force of one of the people. So that's a force of tension, right? But like they don't tell me the direction, which is kind of lame. So here I'm going to draw my diagram. Replace the rope with the dot. I'm going to draw, instead of labeling this tension this time though, I'm just gonna pretend that Taru is pulling to the right. I don't really know. So let's just pick a direction and go with it. Okay, and label it with her name this time. And then I know that the size, the magnitude of this is 16 newtons. Okay. And then, but the rope is accelerating away from her. Okay, so then the acceleration, I'm going to change colors. That is my acceleration value, but that's, okay. That's, I'm going to put a negative sign because it's going the other way, right? So Taru is losing this tug of war. And looks like the other person, Reiko, is winning. So then I'm going to draw the force of Reiko as a larger one. It's probably not to scale, but at this point I don't really know how big her force is. Oops. So then let's just label this instead of tension, because that'll get confusing with two forces of tension. We'll just draw it force Reiko. Okay. And that's actually what they want to know. They want us to solve for this. So, and then, where's force of gravity? I always have that one on here. So let's put that one because the rope has some mass. And then what is holding the rope up and keeping it from falling? Because it looks to me like, when they talk about the rope accelerating, that's happening just sideways. It's not happening up or down. So I'm just going to assume that there's no acceleration up or down, and it's really the two people keeping it from falling. I guess I'm just going to call this it's probably the normal force of their hands, or the tension upward, okay, whatever. I'm not really worried about that right now. I'm mostly worried about the side to side stuff. Okay, so right now I have no formula for force that of a particular person on a rope. That is not a formula I have. So then I'm looking back up at the top here at the formulas in blue, and I do want to use some of those. So looking right away, I don't know Reiko's force. I do know Taru's. So I can't do sum of all forces right now, but I can do mass times acceleration because I do know that. I do know both of those things. So let's do that right now, and let's solve for net force. I've got mass times acceleration, and so that is going to be the 0.75 times, and I'm going to put the negative because it's going to the left on my picture. Now you could have totally drawn this the other way and you wouldn't need the negative. Okay, so then when I do that, let me pause and use my calculator. Okay, so when I did that, I got negative 0.94 with 2 sig figs. Okay. I'm not done though, because that's not what they asked for. So I do need to find this force that Reiko was pulling with. So now I'm going to use the other formula for net force. So let's write that out, net force, and I'm supposed to sum up all the forces. So I would have the force that Reiko is pulling with plus the force that Taru is pulling with. And I could put FG and the other like upward force on there, but I know those cancel, so I'm not going to put them on there. Okay, so now I know this is negative 0.94. And this is the one I'm trying to find. And then Taru is going to the right, so I'm putting that as a positive 16. Then I just subtract 16 from each side. And watching sig figs here, I'm only allowed to keep to the 10th place, right? So then I'm going to end up with negative 16.9 newtons. Okay, so that's my answer. Now, that's at knowing that this could be backwards, okay? So really the strength of her force, the magnitude of this force is 16.9 newtons. And it's on my picture, it goes left. On your picture, it might go to the right. Okay.